Let us look at another method of integration. Integration using partial fractions. So in many of the rational integrals, it makes it easier if we can split the integrand into partial fractions. So let's see what we mean by that using examples. So we have integral x minus 1 by x cube minus x square minus 2x dx. So here we want to split this into fractions, multiple fractions. So first we factorize the denominator. We get integral x minus 1 by x times x minus 2 times x plus 1. In this particular case, we can actually visually do it. X is common to all of them, so x comes out. What we are left with is x square minus x minus 2. And that can be factored into x minus 2 times x plus 1. Now, how do we convert it into partial fractions? This we would have learned long time back. We write it as a by x plus b by x minus 2 plus c by x plus 1. And now we add these three partial fractions. We get a times x plus 1 times x minus 2 plus b times x plus 1 plus c times x minus 2. And the denominator would be x times x minus 2 times x plus 1. Now here the denominators on both sides of the equality will cancel out, and we would be left with x minus 1 is equal to a times x plus 1 times x minus 2 plus bx times x plus 1 plus cx times x minus 2. Let's open up. Actually, we don't necessarily have to open up the brackets. Here, if you notice, x is there, but here x is not there on its own. So let's say x equal to 0, then what happens? This term will disappear, this term will disappear, and here we will have a times 1 times minus 2. That is, minus 1 is equal to minus 2a, or a is equal to 1 by 2. Now, look at this, x plus 1 we have here, here we have x plus 1. So let's make x equal to minus 1. Then this term will disappear and this term will disappear. Only this term will be there. And here, when we put minus 1, minus 1, minus 1, minus 2 is equal to minus c times minus 1, minus 2. So minus 3. So minus times minus plus. So minus 2 is equal to 3c, which is c equal to minus 2 by 3. And similarly, we make x equal to 2. Then this term disappears and this term disappears. So we will have 1 equal to 6b, or b is equal to 1 by 6. So we have got a, b, and c, all the three we have formed. So our integral becomes 1 by 2 times the integral of 1 by x dx, because a is 1 by 2, plus 1 by 6 times integral of 1 by x minus 2 dx, because b is 1 by 6, and then plus c by x plus 1. But c is minus 2 by 3. So minus 2 by 3 times integral of 1 by x plus 1 dx. And these integrals, it is easy to, which means if we integrate this, we get 1 by 2 natural log of x plus 1 by 6 times natural log of x minus 2 minus 2 by 3 natural log of x plus 1 plus c. Don't forget the absolute value signs. And this C is the constant of integration and not the C of the partial fraction. So that was the integral of this integrand. Let's look at the next example. Integral of cos x dx by sin x times 1 plus 2 sin x. Let's see. Let's do substitution. T is equal to sin x, which implies dt is equal to cos x dx. See, by looking at this itself, you should be able to make out that the derivative of sin x is cos x. So immediately you know that you need to do a substitution for sin x. So t equal to sin x, which implies dt is equal to cos x dx, and sin x times 1 plus 2 sin x would be equal to t times 1 plus 2t. So we have cos x by sin x times 1 plus 2 sin x equal to 1 by 2 times 1 plus 2t. And now we find the partial fractions for this. So 1 by t times 1 plus 2t is equal to a by t plus b by 1 plus 2t. Okay, combining these two terms, we get a times 1 plus 2t plus bt divided by t times 1 plus 2t. Again, denominators cancel out and we are left with 1 is equal to a times 1 plus 2t plus bt. Now, let's rearrange this. So we have a times 1 is a plus we have 2at. T is common with bt. So which means we can take it as 2a plus b times t. And now a is a constant, 1 is a constant. So a equal to 1. 2a plus b, there is no t on the left hand side. So equal to 0, which means b is equal to minus 2 because a is equal to 1. So now integral of 1 by t times 1 plus 2t dt is equal to integral of 1 by t dt because a is 1 minus 2 times integral of 1 by 1 plus 2t dt. Again, we know the integrals. So integral of 1 by t dt is natural log of t minus 2 times this integral is equal to 1 by 2 natural log of 1 plus 2t plus c. That 2 and 2 cancels out. So we are left with natural log of t, which is actually sin x, minus natural log of 1 plus 2t, which is 1 plus 2 sin x plus c. So the integral of this is this. So as you noticed, something a bit complicated becomes very simple when you convert it into partial fractions. That was integration using partial fractions. If you found this session helpful, don't forget to like, share, and subscribe. Questions and suggestions are always welcome. Thanks for watching. See you in the next session.